Hey guys, so here are the solutions to the even numbered problems. All right, so again, if you're in class with us today, we did all the odd problems, the even ones for homework. So again, if you haven't done them, please go back and try them, and then again, use this video to go ahead and check your answers. So let's go ahead and move forward. So number one, again, we did in class. Let's take a look at number two. So number two says the specifications for a laptop computer describe its screen as measuring 17 inches. But again, whenever you measure a screen, any kind of screen, laptop screen, television screen, it's normally measured diagonally from corner to corner. So again, that's what measures 17 inches. All right, so diagonally from corner to corner. So it says, how wide is the screen horizontally? So again, we're worried about from P to Q. So again, horizontally, that's the side that I'm worried about. And I want to know that to the nearest hundredth of an inch. All right, so hundredth of an inch, that's two spaces after the decimal. So I will round that at the very end here. But again, our job is to find how wide was this screen. So I'm going to go ahead and place X there. That is my unknown. That is what I'm trying to figure out, the distance from P to Q. I want to figure out how many inches that is going to be. Well, remember, this is our SOHCAHTOA problem. So let me go ahead and write SOHCAHTOA before I forget. All right, and so when we were using trigonometry to find a missing side, it was very, very important that we place our reference angle, right? Where do we place that reference angle? Because it's going to determine everything else. Well, put that reference angle, use that to your advantage. We have a triangle here, right? Take a look at this triangle here. Okay, if you just take a look at that bottom right triangle, it's a right triangle. There's even that 90-degree corner. So I would put my reference angle, let me put that a little bit nicer, from R to Q, and then from R to P. Let me just highlight that a little bit better. So if we're taking a look at that right triangle there, that's kind of half blue, half red, I'm going to place my reference angle here at the 32 degrees. Use that to your advantage. If they give you a degree, go ahead and use that to our advantage. Well, let's continue to label. Remember, if you go directly across that reference angle, directly, just walk across to the other side, that is considered your opposite side. And I'm going to abbreviate it OPP. Okay. And then find that 90 degree, that perfect corner. So I see that it's here. And if I go directly across, I walk across till I hit the opposite side. Sorry, so careful not to say opposite here, right? When I walk across that 90 degrees, that is actually going to be my hypotenuse. Always across from the 90 degrees, always, that one will always be your hypotenuse. That will always be the longest side. That means that the last one over here, of course, is this red bottom side from P to Q. That is my adjacent. That is going to be our adjacent. So at this point, what you have to ask yourself is, well, what do they give me and what are we trying to find? Well, they give us the hypotenuse. They told us that measured 17 inches. And I'm trying to find over here the x, right? The horizontal length, which is considered my adjacent. So what uses adjacent and hypotenuse? Sine, cosine, or tangent? Well, sine is opposite over hypotenuse. Tangent is opposite over adjacent. I'm going to be using cosine. All right, so what does that represent? Well, that's just a fancy way to remember that, hey, cosine of theta is equal to A, which is my adjacent. Whoops, let me write that in there. Adjacent over H, which is my hypotenuse. Let's plug in everything that we know. So I'm going to write cosine, not theta anymore. I actually know theta. What was I using for theta? It's right here. I place theta at that angle 32. So I'm going to say cosine of 32 degrees is equal to, well, what's my adjacent? That's what I was trying to find. So I'm going to leave that as x. That's my unknown. And my hypotenuse is up here, which was 17. All right, well, I have to do a little bit of work. I do want to solve here for x, but I need to get rid of that dividing by 17. How do we get rid of dividing by 17? We do the inverse, which is to multiply by 17. But whatever I do to one side, I also do it to the other. I'm going to kind of have to squeeze that in there. So we multiply both sides by 17, and this is what it'll look like. It'll look like 17 times cosine of 32 degrees. Remember, don't split that apart. Is equal to, and then the 17's canceled out, so we're just left with x. If I can correctly plug this into my scientific calculator, it should tell me the value of that adjacent side. So let me go ahead and switch here to decimals. So 17 times cosine of 32. So where is my scientific calculator? And I'm going to type in 17 times cosine of 32, close my parentheses, hit enter, and there it is. I get 14.416. 14.416. So let me go back. 14.416. Let me just double check that one more time. 14.416. All right, so there we have it. So that again is the value of x, right? That is the distance from P to Q, but I do want to round it. I do want to round that answer to the nearest hundredth. That's 2 spaces after the decimal. So take a look. There's the 1 to the right of it. There's a 6. This is going to be 14.42. We're going to round up. And again, what are my units of measure? This is inches. So that distance between P to Q, that adjacent side measured 14.42 inches. All right, so again, that is my adjacent side. That is how wide, horizontally, that's how wide that laptop is. All right, so problem number 3 we did in class together. Problem number 4. So again, this is another problem where we have to find a missing side. We're going to use our trigonometry here. So I'm going to write TOA before I forget. So it says find the length of side AC. So I need to find the length from A to C. So let me highlight that one. From A all the way over here to C, or from C all the way over here to A, it's the same thing. I'm going to label that as X. So I highlighted it with red so it stands out, but I'm also going to place X. That's what I'm trying to find. And I want to round my answer to the nearest tenth. So this time just 1 space after the decimal. And we give you an example here, something like 5.3. So let's go through. And again, where do we put our reference angle? It all depends. Well, where's the angle that they give us? I see that they give us an angle here. Angle C is 16. So let's put ourselves there at that angle. I'm going to put my reference angle there and begin to label everything based off that angle, based off that reference angle. Again, walk directly across from there to the opposite side. From A to B, we're going to call that is our opposite. Okay. Next, I would recommend find your 90-degree angle. Go directly across from that, walk across to the other side. And that is going to be our hypotenuse. Always across from your 90 degrees, that is your hypotenuse. And then the last one over here, 22, represents our adjacent. Okay, ask yourself one more time. What do we have and what are we trying to find? We have our adjacent. We're trying to find our hypotenuse. Which of those uses adjacent and hypotenuse? Well, sine is opposite over hypotenuse. Tangent is opposite over adjacent. We're not using opposite at all. I need adjacent and hypotenuse, which is cosine. All right, so cosine. All right, so what does that represent again? Cosine of theta is equal to A, which is our adjacent, over H, which is our hypotenuse. All right, so let's fill in everything that we know. So we're going to say cosine no longer of theta. I know what theta was. Let me erase a couple things here. Theta, right, where did I put my reference angle? At 16 degrees. So we're going to say cosine of 16 degrees. That is equal to, what is my adjacent? Well, my adjacent here is 22. And what is my hypotenuse? My hypotenuse is x. That's what I was actually trying to figure out. So there is our trig ratio. We've set it up correctly. It's just a matter of, hey, can you figure out, can you solve and find x all by itself? So we are going to begin by multiplying. Let me find a different color. I need to get rid of this fraction. So I'm going to get rid of dividing, right? Get rid of that dividing by x by multiplying both sides by that denominator. So I multiply the right by x. I multiply the left side by x. This is going to look a little awkward, but follow along. We're going to get x times cosine of 16 degrees is equal to, and then our x is canceled out, so we're just equal to 22. Well, I still don't have x by itself. I did get rid of the fraction, but I still don't have x by itself. So how do I do that? Well, we have to move that cosine of 16, multiplying by cosine of 16, to the other side. The way we get rid of multiplication is to go ahead and divide. We divide by cosine of 16 degrees. Whatever I do to one side, I do it to the other. I'm also going to divide the other side by cosine of 16 degrees. Well, what ends up happening is cosine of 16 cancels out. and we just bring down our x is equal to 22 divided by cosine of 16. If I can correctly plug that into my calculator, that should give me the length of this hypotenuse, which what I was trying to find, the distance from A to C. So let's see what that is going to give us. What's 22 divided by cosine of 16? Let's see. Clear all. 22 divided by cosine, and let me just double check, it was 16. 22 divided by cosine of 16. So let me go back down and put 16. Close my parentheses. I get 22.88. 22.88. Let me write that in here. Find a different color. So when we plug this in here, we ended up getting x is equal to 22.88. But I do want to round my answer. I do want to round our answer here to the nearest tenth of a degree. So again, that's one space after the decimal. So take a look at 8. There's another 8 to the right. So this is actually going to be x is equal to 22.9. That right there is the distance from A to C. All right, so again, our missing side here from A to C, that has a distance of 22.9. Oh, and I forgot to include, right? We'll go ahead and put units, 22.9 units. If they don't give you the units of measure, feet, centimeter, inches, go ahead and just put units. So number 5, we did that in class together. Number 6, take a look at number 6. So number 6 says, we are building a ramp so that people in wheelchairs can access a building. If the ramp must have a height of 8 feet. So again, the height here is 8 feet. They label that for us. And the angle of the ramp must be about 5 feet. So again, we don't want something super, super steep, right? So again, 5 degrees is not too bad, or else people are not going to be able to go up that ramp. So again, here we have a ramp that measures roughly about 5 degrees. How long must the ramp be to the nearest tenth of a foot? So again, how long must the ramp be? So which one's representing the ramp here? Let me go ahead and see if I can highlight it. There's the start of the ramp, and it's going to go upwards, right? The ramp is the one that's going up at an incline of 5 degrees. That right there is the side that we are trying to find. That is going to be our x, right? Not the floor down below, not the height where the 8 feet was. We want the actual ramp. So again, this is another trig problem. So let me write and just like the rest, let's begin by putting our reference angle. And again, they gave us the 5 degrees, so might as well put myself there. Use that to our advantage. So if that's my reference angle where 5 degrees was, if they give it to me, use it. Go directly across, all the way over here. That is going to be our opposite side. So I'm going to squeeze that in there. 8 feet, that represents the opposite side. Here's my 90 degrees. If I go directly across from the 90 degrees, that is considered my hypotenuse. So x over here is my hypotenuse. And then the last one down here is my adjacent. Okay, let's ask ourselves, what do they give us? What are we trying to find? Well, they give us the opposite. I know it's kind of covered up there, but it was 8 feet. And we are trying to figure out the hypotenuse. So what has opposite and hypotenuse? So tangent has opposite, but it has adjacent. Okay, cosine has a hypotenuse, but it has adjacent, and we don't have that. So we're going to go ahead and use sine. We're going to use sine to our advantage. So what does SO and SOHCAHTOA represent? That's saying that sine of some reference angle is equal to O, which is our opposite, over H, which is our hypotenuse. Let's fill in everything that we know. We're going to write sine, no longer of that reference angle, no longer sine of theta. We're going to use theta here represented 5 degrees. So we're going to say sine of 5 degrees is equal to the opposite side, which is way over here, which was 8 feet, over my hypotenuse, which was exactly what I was trying to find. So let's put x there. All right, let's go ahead and multiply both sides by x. So if I multiply the right side by x, whoops, let me find a different color. Whoa, all right, technical difficulties, but I think we're back. So let's multiply both sides by x, right? Let's get rid of that fraction We get rid of dividing by x by multiplying. So if I multiply the left side by here by x, this is what it'll look like. X times sine of 5 degrees is equal to, and then our x's canceled out. So we're left with just 8. We have one more thing that we have to do before we can plug it into the calculator, just like the last one. We're going to divide both sides here by sine of 5 degrees. We're going to divide both sides by sine of 5 degrees. So on the left, sine of 5 degrees cancels out, and we're left with x is equal to 8 divided by sine of 5 degrees. If we can correctly plug that into our calculator, it will tell us how long the ramp must be, and then we'll round it to the nearest tenth of a foot. So let's go ahead and plug that into a calculator, into our Desmos calculator, and I'll write my answer over here. Once I get it, x is equal to, what is 8 divided by sine of 5? What is 8 divided by sine of 5? Close my parentheses, hit enter. I get 91.78. 91.78. So let me write that in. 91.78. But of course, we do want to round it. We do want to round this answer to the nearest tenth of a foot. So again, one space after the decimal, that's the tenth place. So if I take a look to the right, that means that x is equal to 7 there to the right, it's an 8. So we are going to round up to 91.8. And this is going to be feet. So that right there is our final answer. That is, okay, how long the ramp must be, 91.8 feet. That's a pretty long ramp. So there you have it. That's the solution for number 6. All right, number 7 we did in class today. Take a look at number 8. Okay, so it says, Kristen is swimming in the ocean and notices a coral reef below her. The angle of depression, so the angle of depression, that's just saying because now this angle is forming and it's going down. It's not angle of elevation, it's going down. And the depth of the ocean at that point is 250 feet. So here they tell us, hey, the depth to that coral reef right there, that is a total of 250 feet. They're asking us, what equation can be used to determine x, her distance to the reef, right? So she's over here, she's swimming. How long is it going to take her, right? What's that distance? What's that distance all the way over here to the actual coral reef? So that's what our x is going to be. And it's just asking, what is the equation? What equation? So just again, set up the equation, set up the equation. Let me go ahead and finish closing up this triangle so we can see that, hey, there is a 90-degree triangle being formed here. All right, let's start off by labeling it. Oh, actually, not even start there. Let's start by writing SOHCAHTOA. SOHCAHTOA. I need to write the equation, right? Is it going to be using sine, cosine, or tangent? So let's take a look. Let's go ahead and label everything. I'm going to put my reference angle where I see the 35 degrees. Use that to my advantage. If I go directly across from that, that is my opposite side. So that 250 feet, that's the opposite side. Across the 90 degrees, I found my 90 degrees. Let me go across that. That is my hypotenuse. And that means that the last one up here is the adjacent side. Well, what do they give us? What are we trying to find? They give us the opposite side. I'm trying to find the hypotenuse. What uses opposite and hypotenuse? That is going to be sine, not cosine, not tangent. Those other two use adjacent, which I don't have. So again, so in SOHCAHTOA, what does it represent? What does it represent? What's the equation for sine? Sine of theta, well, is equal to O for opposite over H for hypotenuse. So fill in everything that we know. Fill in everything that we know. This is going to be, again, what is the equation? Let's go ahead and write it. Sine of, what is our reference angle? What is our reference angle? That was 35 degrees. So we're going to say sine of 35 degrees is equal to the opposite side, which was 250, over the hypotenuse, which was my x. And that is it. That is it. That is your final answer. All they wanted, whoops, I don't know what happened there. All they wanted was the actual equation. All right, so again, all they wanted was the actual equation. All right, problem number 9 we did together in class. Take a look at problem number 10. It says, to the nearest tenth, find the lengths of AC and BC. So I actually have to find two sides. It says, to the nearest tenth, find the length of AC. So from A to C, and then from B to C. So let's start off here from A to C. We'll work with that one first. And I'm going to write SOHCAHTOA. I'm going to squeeze that up top here. SOHCAHTOA. So if we are trying to find this angle here, this side from A to C. Let me go ahead and place X there. And let's begin by putting our reference angle. Where are we going to put our reference angle? Well, put it where they give you that 52 degrees. Walk directly across from there. Walk across, touch that other wall. That is considered your opposite. Find that perfect 90-degree corner. Walk across that one. That is going to be our hypotenuse. Always across that 90 degrees is your hypotenuse. And then the last one over here, of course, will be our adjacent. Last one there will be our adjacent. So let's go through and figure out what is the length from A to C. So what do they give us and what are we trying to find? Well, they give us the opposite, which is 12. We're trying to find the hypotenuse. What uses opposite and hypotenuse? That is sine. Okay, so sine. Okay, whoops. Sine of theta is equal to O over H, which is opposite over hypotenuse. So fill in everything that we know here. Sine of, what's our reference angle? 52 degrees is equal to our opposite side, which was 12, still circled over there as 12, and then our hypotenuse, which is what we're actually trying to find, which is going to be x. This is going to take us 2 steps. We multiply to get rid of that fraction. We multiply by that denominator, multiply both sides by x. All right, and we bring down x times sine of 52 degrees is equal to, well, our x is canceled out, so we're just equal to 12. We got one more thing we have to do, which is to divide both sides by sine of 52. When I divide both sides by sine of 52 degrees, sine of 52 cancels out on the left, but I'm left with x is equal to 12 divided by sine of 52. If I can correctly plug that into the calculator, it will tell me the distance from A to C. It will tell me the distance from A to C. So let's see if I can plug that in correctly. 12 divided by sine of 52. So clear all this. 12 divided by sine of 52 degrees. On decimals, that gives me 15.22. 15.22. So x is equal to 15.22 units. And we're going to round to the nearest tenth. So that's one space after the decimal. There's the 2. To the right of it, there's another 2. So we're not going to round up to 15.3. It's going to stay as 15.2. Okay, so 15.2 units. That right there is the distance from A to C. That is our hypotenuse. So I'll erase that, and I'll actually draw this little arrow so that it actually points at AC. Okay, so here's the thing. We're done finding the distance from A to C. What about from B to C? Let me see if I can highlight that in a different color. I'll use blue. From B all the way to C, do I necessarily have to go through, this is my new X. Do I have to go through and relabel everything? No, use what was already there. Use what's already there. Whoops, all right, I had technical issues. I gotta erase, a couple things. Technical issues. All right, so yeah, we don't have to reset the problem to figure out the distance from B to C. So from B to C, again, it's right here. This is our new X, which as I labeled before, that was our adjacent. So which trig function is going to help us out now? Again, what do we have and what are we trying to figure out? Well, we have the opposite side and we're trying to find the adjacent. So what uses opposite and adjacent? That is going to be tangent, right? Tangent, or that TOA piece there for tangent. Tangent of theta is equal to O, which is our opposite, over A, which is our adjacent. Well, let's plug in everything that we know here. So let me change colors. We're going to write tangent of 52 degrees is equal to the opposite, which is 12, over the adjacent, which is x. Just like the last one, we're going to go ahead and multiply both sides by x to get rid of that fraction. So I'm left with x times tangent of 52 degrees is equal to just 12 because the x's cancel out. Well, if I divide both sides now by tangent of 52, that should give us x all by itself, and we can go ahead and plug that into the calculator. So we're left with x is equal to 12 divided by tangent of 52 degrees. Again, if we can correctly plug that in, it will tell us the distance from B to C. It will tell us the distance from B to C. So what is 12 divided by sine of 52? I thought I had done it, but it was tangent of 52. 12 divided by tangent of 52, that is equal to 9.37. So that is going to be x is equal to 9.37. And again, if we round to the nearest tenth, that's the tenths place. To the right, there's a 7. We are going to round up to 9.4 units. So the distance from B to C, this adjacent side measures 9.4 units. All right, 11 we did in class together. Take a look at number 12. This is getting to the more recent stuff, the last unit test that we took last week on dilations. What are the coordinates of the image of point F? So we're worried about point F after a dilation of a scale factor of 4 centered at the origin, right? So you could go through. So let me highlight the scale factor of 4. And again, it's centered at the origin. So you could go through and give all the coordinates and dilate all the coordinates. But again, all we're worried about is coordinate F. So take a look at coordinate F. F is sitting at right now at 2 to the right and -2 down. So it's sitting at 2, -2. What we want to figure out is just the new coordinates for F. So you could go through and dilate F, G, and H, right? Just apply your scale factor, right? What do we mean by apply your scale factor? You would multiply by 4, but I'm only worried about F. So if I multiply both the X and the Y values by 4, what does that tell me about F prime, right? What's the new image? What are the coordinates for the new image? Well, that's going to be at 2 times 4, that's 8. -2 times 4, that is -8. That is your answer right there. Those are the new coordinates. You don't necessarily have to dilate the entire picture itself. You could have gone through and done it. But again, those are just the coordinates for F prime. And again, the only reason I was able to apply the scale factor that quickly, it's because it was from the origin. When it's from the origin, right, the origin is 0, 0, use the coordinates. That's why I was using 2, -2, because that was the location of F. And then just multiply by your scale factor. All right, so that is the answer to problem number 12. Okay, 13 we did in class. Take a look at 14. 14 says, what is the length of A prime C prime after a dilation of 1/3? So this is going to be a reduction. It should shrink it with the center of the dilation at point A. So this time I can't use the coordinates, all right, because we're not centered at 0, 0. So A is our anchor point. That is the center. That is the center. Everything's going to shrink because our scale factor is 1/3. Everything is going to shrink towards A. And again, we're only worried about the length from A to C. Well, from A prime to C prime. Well, from A to C right now, what is that distance? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was a distance of 9. What is that distance going to turn into, right? So we had a distance of 9. If we apply that scale factor, which means you just multiply by that scale factor, which was 1/3, well, that's 9. Let me go ahead and change colors here. 9 over 1. If I multiply across the top, 9 times 1 is 9. 1 times 3 is 3. 9 divided by 3 is 3. That is the new length from A prime to C prime. That new length is going to be 3 units, right? So that distance that used to be 12 would only go up 1, 2, 3. This would be your new C prime, and of course A, since it didn't move, that would also be your new A prime. That distance would now look like that. So that's all they were asking for. What is that length? You don't necessarily have to dilate the rest of it. You could if you really wanted to, but you don't have to.